With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is shown that there are two concentric coplanar coils. The radius are A and B, where B is very greater than as compared to A. That means here it is given in terms of A1 and A2, but here basically our A2 would correspond to B. So this A2 is equals to B and A1 is equals to A. Now there is a current I equals to 2T which is flowing through the smaller loop. We need to neglect the self-inductance of the larger loop and we need to find what is the mutual inductance of the two coil, the EMF induced in the larger coil, and also the if the resistance of the larger coil is R, we need to find what is the current as a function of time in the this larger loop. Now first of all, we just assume that let's suppose that this I amount of current is flowing through this wire because we need to find the mutual induction of the two coils. So basically it does not matter whether we are considering this flux due to this coil or this coil while calculating the mutual induction, because it would come out to be same. Why? Because it is just a mutual induction. So we say that for the A part. So if I is the amount of current which is flowing through this wire, what is the magnetic field of this due to the current flowing in this loop at the center? Because this is very small. We say that this is small a, or this is a very small we can say that the coil. So we can just assume that it is lying at the center itself. So we can just find what is the magnetic field at the center. So it would be equals to mu naught I divided by 2b. This is how we write. So it is written as mu naught I divided by 2r, where r is the radius. So for this part, the radius is equals to b. Okay, this is our b. So what would be our phi? We know that phi is equals to b into a. Now this magnetic field is linked with this. We can say that this our coil. Okay. Now we can say that this would be equals to mu naught I divided by 2b. And what is the area for this coil? It is equals to pi a square. Okay. Now, if this is our this flux which is linked with the smaller coil, so we can say that what would be the value of the mutual inductance? We say that mutual inductance is phi divided by I. So if we divide this expression by I, so we get the value as mu naught pi a square divided by 2b. So this is the first part. Now in the second part, what we need to find? We need to find the EMF induced in the larger coil. What is the EMF induced in the larger coil? So EMF, this would be equals to d phi divided by dt. Okay, this is the EMF. Basically, EMF is written as d phi over dt. Now, in this expression, if we put the value of the current, because we need to find what is the EMF induced in the larger coil. Okay, so what we can do, it would be basically, that means that this EMF would be developed due to the current flowing in the smaller coil, which is equals to capital I. So we can say that d divided by dt of what? Mu, and the current value would be the current in the smaller coil, pi a square divided by 2b. Now, what is the value of I in the smaller coil? It is given as to be 2t. So here we can say that all the terms are constant. So it would be mu naught pi a square divided by 2b. These terms are constant. It would be just differentiation of I. Now, if we just differentiate this expression, we get the value as only 2. So we can say that if we just multiply it by 2, so EMF induced, it would be equals to mu naught pi a square divided by 2b. Now, in the C part, we need to find what is the value of the current in the larger loop. Now we know the resistance, so I value would be equals to induced EMF in the larger coil divided by the resistance. So it would be mu naught pi a square divided by b into r. So here this 2 is already cancelled. Okay, we have already cancelled this 2 here. So this is the current. So basically it is not dependent upon the time. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.